Okay, now members, we have a very different question here. It's also nice, so let's go through it and see what happens there. The acceleration of a particle is, we are going to read it as we pull out some question information, is negative 10j. So this is a vector, which is okay. If a particle starts at, so they are giving that as according to this, so this will be the initial position, and you see that it's in the ij. So meaning that this is in the ij with the velocity of 15I, that's also in the ij. So you always base on one point to see how many spaces we have. So this one is in ij, we don't have k. Find the velocity after time t. So let's summarize. So they are telling us that the acceleration is a equal to negative 10j, which I can easily write as a color vector, which is 0, negative 10 meters per second squared. Because why am I having 2? Because I'm seeing the point is given in the ij. So from there, I'm telling me that the velocity, so this is going to be my initial velocity. So my initial velocity, they are telling me is 15I, of course, meters per second, which is going to be. So instead I don't have the j component, so this will be just 15, 0, because I'm missing the j component, and this will be meters per second. So after that, they are telling me that find the velocity at time t equal to this. So they are, in the simple terms, they are asking for the final velocity after 5 seconds. So using this equation of motion, so my v, I'm looking for it's going to be now my initial velocity, which is 15 or then plus my acceleration, which is 0, negative 10. Then this one is going to be multiplied by t, which is 5. Our t is 5 from that question. So my final velocity here will be 15 or then plus 0, then minus 15. And so my velocity here is going to be 15, then negative 15, which I can easily write as 15I, then minus 15j. These are meters per second, and that will be our answer there. But you can do this. This is just what you can get from here. You can do this answer. Okay, that is okay. Then part B, this is our part A. Then part B, given that at time t, the particle is at this, under the value of x and t. Now here we are going to bring displacement beside it. Our displacement at t is always given by r of, then plus s, the displacement there. So our rt, what is our s? We can easily get our s first. Okay, so if here I'm using capital T, and which is now capital T, because the time we invested in is going to be also capital T. So now my RT is going to be RO, then plus my S. What is my S? But my S is going to be equal to UT, now capital T, then plus half a capital T squared, because we are dealing with this sign here. So my S there is going to be my U. What was my U? My U here was 15 or into T, then plus half my acceleration was 0, negative 10 into T squared, which I'm looking for. So from there, you can set my S is going to be, my S is going to be 15 or, you see, half of this is going to be N. Then plus, when half of this is going to be 0, so I have 0, then half of this is going to be negative 5, the whole T squared. So from there, I have what my S is. I can even add. So this would be 15, this plus this is 0, then this it would be negative 5 T squared. When I add this 0, then get get that. So from there, my R capital T is going to be R of plus S. At any time, they're telling me that it's going to be at this point. So from there, my R at T at any time is going to be at X, comma, 0. Now in this one, they are giving us as a point. So now I'm going to write them as a displacement, as a form vector. Now, what was our initial point? Our initial point here was RO, which is 0, 80. So this is where the particle was before it moved to this point here. So whenever it moves to a certain point, it's what we put here. So it moved to XO equaling to from which point? 0, 80, then plus our S, which is 15, then negative 5 plus T squared. And the vector, as I said, you can get this plus this plus this. So remember, we forgot the T here, we forgot that T, but finally it is back, this T here. So finally it's back there. Okay, so now start this, so our X will be 0 plus 15T. So our X here will be 15T. And also from here, so that now our 0 will be equal to 80, then plus negative 5 plus T squared. So what happens after? We get T. So this is going to be our 0 equaling to, sorry, this is 5T. I don't know what's happening to me. This is just T squared. Note that this is T squared, please. Okay, sorry for that. This is T squared, then this is going to be also T squared. So when I take A to this side, then when I take this side, I have that, then this one remains positive. So my T squared is going to be 16, taking the square root. Okay, T squared is going to be 4, 2. Powers are the same. Because this is time, I don't expect any negative. So therefore, my T is going to be 4 seconds. Why? I'm using this because I know time can't be negative. So from here, we say our X is going to be 15T. So our X is going to be 15 times our T, which is 4. So our X is going to be something like 60. Now these are going to be in meters. So that's it, members. Otherwise, sorry for these two mistakes here. This T, and then when multiply I will get that. And then here, when multiply this, you get this. But after writing, I was forgetting it. Yeah. So that's it, members. I wish you well.